All right, shall we get into it? There's no reason to delay at all. Advent of Code 2018, Day 12. Subterranean Sustainability. The year 518 is significantly more underground than your history books implied. Either that or you've arrived in a vast cavern network under the North Pole. After exploring a little, you discover a long tunnel that contains a row of small pots as far as you can see to your left and right. A few of them contain plants. Someone is trying to grow things in these geothermally heated caves. Pots are numbered with 0 to the front of you. To the left, the pots are negative 1, 2, 3. To the right, 1, 2, 3. Puzzle input contains a list of pots from 0 to the right and whether they do, hash, or do not, dot, currently contain a plant. The initial state. No other pots currently contain plants. For example, an initial state of hash dot dot hash dot 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 indicates that pods 0, 3, and 4 currently contain plants. Okay. Your puzzle input also contains some notes you find in the nearby table. Someone's been trying to figure out how these plants spread. All right, so this is like a one-dimensional game of life thing. Based on the notes for each generation of plants, a given pot has or does not have a plant based on whether that pot and the two pots on either side of it had a plant in the last generation. Well, that's fun. These are written as LLCRR arrow N, where L are the pots to the left, C is the current pot being considered, and R is the pots to the right. That's confusing. Okay, I see. Yeah, a note like this means that a pot contains a plant, but no plants within two pots of it will not have a plant in it during the next generation. Blah. Okay. I think I understand. This is just basically mapping out. We have this initial state of alive and dead cells, and this maps the live. Well, this looks like it's just live. For brevity, in this example, only the combinations which do produce a plant are listed. Your input includes all possible combinations. I guess, you don't really need the opposite ones because you can assume that if it doesn't match the pattern, then there's no plant produced, right? The next 20 generations will look like this. Okay. Yeah, okay, I'm following it. The generation is shown along to the left where 0 is the initial state, right? The pot numbers, oh yeah, so it can go negative. Okay. We'll have to keep that in mind. After one generation, only 7 plants remain. The one in pot 0 matched the rule looking for this, and one in pot 4 matched the rule for that, and blah, blah, blah. In this example, after 20 generations, the pot shown as hash contained plants. The first to the left is -2. The first to the right is 34. Adding up all the numbers of plant-containing pots after the 20th generation produces 325. After 20 generations, what's the sum of numbers of all plots which contain a plant? Okay. So step 1 is we're going to create our template. That's 18 mod. Yep. Do that. Do that. 1812. Go back here. Oops. Right. I'm going to get used to this at some point. I've only been using Vim for a million years. Day 12. Okay, so this should build now. Oh, it doesn't build. Why? I did a mud thing again. I keep doing mud. And if we save this, now it should go back to unsolved. Perfect. All right, so here's where our thing is. Let's get our input, 2018-12. Okay, there's only 34 lines. That's not too bad. Well, there can't be Wait a minute. There's 34. Oh, okay. Yeah, there's the initial state, a blank line, and then 32 rules. And there can only be 32 rules. Okay. Because it's 2 to the 5th. All right, so parsing this is we're going to grab the lines. And the code I wrote skips blank lines. So the first line is going to be, and this is just a vec, right? Yeah, so the first line is going to be the initial state. And we're going to store that in our struct somewhere. We don't care about the word initial state, right? It just had initial state colon, and then it had the initial state. So we're gonna split on this and grab the second half of it, right? Line 0 dot split once of colon space unwrap. So this should give us our initial state as a string. Now we're going to be messing around with ons and offs. We could keep storing it like this as a string of these things, or we could store it as a vec of bools. I don't know what makes the most sense right now. We could do bools, right? Initial state, vec of bool. Oh, no, we can't. We can't, right. I forgot. So we have this offset here. And we don't do, in vecs, we don't do negative indices. So how do we keep track of the 0 point? Maybe we can just store it as an offset and say, this 0 point, we're going to call this 0 point of 4, which means that the fourth entry in is, yeah, we could do that, right? We can just put a 0 point, which is use size. And the 0 point is going to start off as 0. Smab, hello. Haven't seen you in a while. Smab says, I'm also doing 2018 to prepare, and you're on day 13. Okay, very cool. Where's the .NET Conf this year? I've never been. So this should just say initial state is equal to iState chars, right? We can grab the chars. So we're going to map each character from here, and we're going to change dots to true, false, and we're going to change hash to true, and we're going to panic on everything else. Which shouldn't happen, and then collect vec. Okay, so this is a vec of bool, and now we can just set the initial state. Self initial state is this, and then self 0 point is 0. Right, and now we're going to need to do the translations. What's an efficient way to store the translations? What we can do is just convert them to numbers and stick them in a hash set. And all we have to do is save the ones that parse into something that turns on. Right, and then we can just look the number up in the hash set and say, does this value here get the next generation? Let's try that. And what are these called? What's the term they're using here? They're notes. Tediaz, thank you for the follow. Very much appreciated. Welcome. So these are the notes. Let's call them notes. Hash set of, and we'll just, I guess we can just keep using use size because we don't need negatives yet. And then basically what we'll do is we'll convert this into a number, like this is 3 and this is 4 and this is 8, right? So it's a number from 0 to 32, and we stick it in the hash set if the next generation has a new pot and it's not in the hash set if it isn't. I have no idea if this is going to be a good way to do it or not. So, but the best way to find out is to just give it a shot. Wait, did that rhyme accidentally? So for line in lines, iter, skip one, right? We're skipping the initial state line here, and it's just going to look like this. So we can split once on this. Let left right equals line dot split once on this unwrap. And now I want to convert left into a number if right is equal to this thing. Now right should be a stir. So I can say if right is equal to this. That should work. Let's try it out. Let's just print all the lefts that have the right that way. And then down here what we can do is we can print out the initial state. Well, we can do that here. A couple of failures. Oh, that's not a function. Okay. All right, so we have a bunch. Let's see if it's even right. 18-12. True, true, false, true, true, false, true, false, true, false, 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 false. Okay, that all looks like it worked. And then we're going to look just for these here that have hashes on the right. And looks correct. I don't see this one. Right? Yeah, okay. So now we just need to convert these into numbers. So yeah, we can just say self notes insert, and then I'm trying to think what's the best way to do the conversion. We can just make a little trait, left.convert, trait conversion, fn convert, takes a self and returns a usize. Impl conversion for stir, fn convert, self usize. Oops. Let mut result equals 0. And then what we can do is just walk the characters and shift and add. While for ch in self chars iter, because self is a string. Ooh, can I do that? I don't know if that's going to let me do that. It shouldn't matter though, right? Self chars iter. We're going to multiply result by 2. Shift up by 1, and then say result plus equals ch is equal to hash. I think that'll do the conversion, and then result. So let's just double check. Let convert conv equals left convert. Println left conv, and we can just double check to see if this all works. Oh, we can just do chars. Cannot add a sign. Oh, right, as usize. All right. Does that look like a 14? It does. Does that look like a 29, 30, 30? It does. Does that look like an 18? That's 16 plus 2, 18. I think we got it. I think we got it. Okay. So now we have all of the notes, and we have a vector of these things. Now we have to do the hard part. The easy part's done. There. Okay. How are we going to do this? Because we need to keep track of whether or not our 0 point moves. We could say, I'm going to increment the 0 point every single time and then shift it down, right? Because we're going to need to compare entries to the left. So in order to insert 2 entries at the beginning though, maybe I need to be a little fancier here. Right, because what I'll do is I'll add 2 entries, and then so all of these need to be pushbacks. Can I collect into a vec deck? So if we want, we can start here with pushing 2 falses to the front. Does it make sense to store these all as binary? Because now I have to convert them into numbers again. I don't know a good way to store all these things. Well, let's find out. Let current state equals self initial state clone. Right? And I will say current state push front false false. This is going to be in a loop, but I want to get one generation done. And now what we can do is loop over each one of these and take 5. Can we do a take 5 or a Windows 5 on this? Oh, we're going to have to push back also. It also means the 0 point changes. Let current 0 point is equals to self 0 point plus equals 2. And then current state push back false false. And now we can do iter Windows 5 maybe. Let's find out. For group in current state iter Windows 5. I'm just going to print them out for now and see if it even looks correct. Oh, I keep doing that with the initial state. There's no method name. Oh, that's right. It's on a slice. Can I do an as slice here? I don't know if that works for, as slices. Oh, right. The way vecdecs work is it's a pair of slices. I forgot. I guess what we can do is maybe, can we do an into slice? Let slice equals current state try into as mut slices. Oops. Drain pop front intermute shrink to make contiguous. So I could do a make contiguous and then get the front slice, right? Rearranges the internal storage of the deck so that it's one contiguous slice, which is then returned. Oh, okay. It returns the one contiguous slice. Does not allocate and does not change the order of the inserted elements. As it returns a mutable slice to be used to sort a deck. Once the internal storage is contiguous, the as slices and as mut slices methods will return the entire contents. But this will return the contents as a slice. Okay, so make contiguous seems to be the way to go here. Right, I could just change that here. Make contiguous. And then it returns a slice, so I should be able to do Windows 5 on it. Yeah. All right, so is this even close to being right? It should be false, false, true, true, false. And then false, true, true, false, true. right? And then true, true, false, true, true. Yeah, okay. So we now have that pattern done. The next thing to do is to figure out how to convert this group from an array of bools into a number. I have a way to do an array of strings. Let's do array of bools. Impl conversion for bool. Usize. It's the same code. Do I have to say self iter? Or can I just say self because it's already a slice? Result plus equals bool as usize. Doesn't like that. Oh, okay. But mismatch type except usize found unit. Self is unit? Oh. Okay, so can I do iter? Casting that, okay. All right. And now what we can do is convert it this way. Yeah, that was fine. And then that, and then we can do that, and then we can say group.convert. There we go. So that's 6, correct. That's 13, correct. That's 27, correct. Okay, so now we're converting it to a number, and now we can look to see if it's in the hash set, right? And what we'll just put here is a Boolean. Say self notes contains let's see equals group convert C contains C, like that. And then so for each one of these where it does contain it, then we insert it into our next state, which we haven't created yet. So let's create that. Let mut next state equals vec. And then that's all we're going to do, right? So we can just say, CF equals, there we go. Next state dot push back. Group convert self notes contains group convert. Right? And that'll be the next state for our there. What's the warning? Oh, we're not using current ZP. Right. So now we can throw away any false entries in the beginning. And then we're going to have to loop over this 20 times. Okay, so we'll put this in a function, right? To just do that 20 times. And then what do we need to return? The pots, sum of the numbers of all the pots that contain a plant. Okay, and then, yeah, so what we can do now in order to stop this from growing by 2 every time, we can strip away any falses at the front, any falses at the back. Anytime we strip a false from the front, we have to subtract 1 from the current ZP. I wonder if I should do it with the test input first. Couldn't hurt, right? No, let's just do it and see what happens. If I get it right, then yay. If I get it wrong, then I'll do the test input. Okay. So we can just do this for underscore in 0.20. Actually, we want to put this in the loop without this here. Why did I delete the mute? I didn't. Okay. I'm getting confused. Oops, wrong direction. And then we'll figure out how to calculate the answer. All right, so yeah, let's just strip this down. I guess it's only 20 generations, so who cares, right? All right. And it takes less than a millisecond to run. Yeah. All right. So all we need to do now is add up calculate the answer. So we can say we're going to loop over the current state. And if the current state has, so we can say current state iter enumerate filter index and pot, right? Is that the right order, or do I have it backwards? That's correct. Okay. So we're going to say if pot filter all the pots, and then what we'll do is we'll say fold 0, and we're going to get the index and pot again, right? Oops, I got that backwards. What goes in here? Should be the index and pot. Oh, and then the value. Oh, we can't. Why doesn't that work? It takes one argument. Wait a minute. What am I doing wrong? Oh, expected closure takes 2 arguments. No, this is going to be the sum and then the index and pot, right? There we go. Okay. I'm an idiot. Apologies for being an idiot. And now all we need to do is add up. Oh, we don't care about the index at this level here. Oh, we do. Because we have to use the index to determine what we're folding over. So this is going to be sum plus index minus current ZP. And is there a name for this value, or is this just the sum of all the numbers? Let val equals, and then we can just return val here. Can I subtract unit? Index is u size, current ZP is unit? Why? But I'm assigning it right here. If the problem is if I assign 0 here, it's going to complain that that's, oh, +2. Current ZP is used here, but possibly uninitialized. Okay, we can fix that. This is saying if the for loop runs 0 times, that's true, but it can't. It can't run 0 times because it's guaranteed to run 20 times. And we don't need the index in the filter, and we don't need the pot in the fold. 4270. That's not the right answer. Answer is too high. Okay. It's whatever our index is, 0 minus our current 0 point. Okay, so this is where we have to, we'll use the test input. Let's just call it test input. And then test input, and let's grab this. Copy, paste. And what we can do is for each generation, we can just print out what we have. And so that way we can see what's going on. So our first generation should look like this. So after we're done here, yeah, it's gonna get wider and wider by 2 each time. Okay, I can live with that. For val in current. Oh, I'm an idiot. I never set the next state. Let's see if that's the bug. Oh, I panicked. attempting to subtract with overflow on line 70. Oh, right, because these are these freaking U sizes. We can't go negative with U size. That's a U size, and that's a U size. So I have to say as I-64, as I-64. 94. Does that make sense? Nope, that's not the right answer. But it's not saying it's too low. So I must be close. All right, now we... Okay, it's because we were using the test input. But I still have the wrong answer. 320, it should be 325. So let's print out the generations as we get to them. For val in current state iter, if val then print bang hash, else print dot println. Really? All right, so this doesn't look right at all. So our first thing has something here, which it's missing stuff. Okay. Let's see. It should be looking at ... hash ... which is this one. So it should generate this, which is there. Oh, I wonder if this is messing things up, because I'm doing a next state pushback at the beginning, and I'm moving the 0 point. So I do need to insert a couple, I think this is what needs to happen. Yeah. Not quite, because now we got double hashes here. But it is shifting up, which is what I was expecting. But it's still not doing the conversion correctly. And I'm not sure what would be going wrong, unless, I'm not converting the numbers correctly, but I thought I was. So let's just do it step by step. And that way we can see what's going on. Let v equals group convert. Let b equals self notes contains v. And println v and b. And that way we could we'll just do one generation. And I forgot the closing brace, bracket, paren. All right, so it's saying true for 4. So this is here. Our first, because we're starting, this is what our initial state looks like, right? So I stick 2 zeros at the beginning and 2 falses at the beginning, and then so our whole thing looks like this, right? Yeah. So the first one is a 4, 1, 2, 4, and it's saying true. So it should get a true there. And I already put the ... in front of it. So it's true. The next one is a 9, right? And it's saying 9 is false. Correct. So it should get a dot there. and it does. Then our next 5 are these, so it's 18. And 18 doesn't have an entry, so that's a false. So it gets a dot. So all these are working. And then I get that. So that works. This first generation works. So why wouldn't the next generation work? Let's do 2 generations. The second generation is going to be this part. It's not showing here, but we're going to get a false there. Sorry, here. 1, 2, 3, 4, 5 is a 1. That's correct. And that's a false. And then the next value is a 3. Oh, sorry. Yeah, the next value is a 3. And that's, 2, right? And a 2 is not set, so that's false. That's these 2 dots here. The next value are these 5, which goes back to 4, which is true, and we get that. Okay, so this is working. Oh, no. Oh, yeah, 4 dots here, and then 2s, 2s, 2s. Oh, we're missing this last guy. We're missing that last guy there. We're doing this 4 here. But then, oh, do we need to stick? Oh, we have to stick like 5 at the end. Right? Not just 2. Okay, let's try that. I don't know how much of a difference that's going to make. But now we have this correct. All right, so let's do 3 generations. Let's get rid of this part here, and we'll just print out the generations now. Schminjin Progress. Thank you for the follow. Welcome. All right, so now the 3rd generation looks like this and this. That looks right. So how come 20 generations is wrong? Because I'm getting 1047 for the value here. Oh, it's right. It's right. I'm just doing the calculation wrong. This looks all correct. Yeah, this looks all correct. Okay. It's just that my 0 point must be not being maintained properly. I'm incrementing the 0 point by 2 each time because we're pushing 2 extra ones at the front, so that shoves over the 0 point by a couple. And we subtract that out, it should be resetting things to 0. So I need to figure out why it's not coming up with 325. All right, we can get rid of this. And it would be nice also to strip out the falses in the front and the back after the conversion's done. I don't know if there's an easy way to do that. And then I can print out the 0 point for each level. And then we can look to see if it makes sense, right? We can say, if we're just copying it over, I'm trying to think how bad this would be. Let mut iter equals next state iter, while let some true equals iter next, current zp minus equals 1. And then that means we hit a true. So current state clear. Current state push front false. True, because we just found a true. And now we want to finish out the iter. Can I do this? Current state extend by iter. That won't clear off the ones at the end, but it'll at least clear out the ones at the beginning. And I can just print out the 0 current ZP. Oh. Oh. This has been in there the whole entire time. Still coming out with the wrong number here, 28. Two, 4, 6, 8, 10. No. It should be subtracting from ZP here. Well, I messed this up again. Wait. I broke it by doing that. So we're gonna comment this part out, and we're gonna just say current state equals next state, and do this again to unbreak it. Now it's 325. So now the calculation is correct. I got to figure out how I can strip out all these initial falses without breaking it. Okay, and do I need all 5? I guess now that I have that fixed, do I need all 5? Yes, I need. There we go. So I just need 3 at the end. Why is that the case? Let's see if we can brain it out here. So we want to do these 5, and then we want to do these 4 plus 1, and then we want to do these 2 plus 2, and then that's it. It should only be, yeah. Oh, I guess it doesn't say. It should say what happens on the edges. I guess it's infinite. Yeah, so we'd need 4 at the end, because it could be infinite, and then we know the rest are all zeros, and we'd need 4 at the beginning. So 3 works, but 4 is safer for the real input. Yeah, and this is why we want to strip these out. But let's do it with the real input and see if we can get the right answer. 3890. Okay, that's the right answer. Smab says current is in the middle of the 5 pattern, so you need 2 at the start and 2 at the end. Yeah, but if the end finishes with, like if we have a whole bunch of things here and it ends on a hash, right? And what if there's a pattern? There could be a pattern that goes hash ... equals hash. Then this theoretically has ... dots after it, infinite dots. That's the way I read the problem. So you could have one that SMAB says it can only reach 2 to the side of the current calculation. All right. Well, maybe that's in here and I just missed it. Let me try it with 2 and see. Let me get rid of the print statement. Let me try it with 2. Yeah, see, 2701. And if I do 3 here, 3856. Now if I do 4, 3856. What did I put for the answer? 3890 is the answer. So that doesn't work there. If I do 3 at the front, oh, I know. No, that's right. Change this to 3. Now it's 3890. That's why I'm thinking it has to be 4 on each side. Or there's a bug in the rest of my code. So let's get rid of that. And yeah, I'll leave that line in there. Okay, that's good. Oops. I forgot what I changed. Okay, get status. RM. I guess we can leave the test input in case we need it for part 2. Git add source. Git commit -am 2018 day 12 part 1. All right, let's take a look at part 2. Here, continue to part 2. You realize that 20 generations aren't enough. After all, these plants will need to last another 1,500 years to even reach your timeline, not to mention your future. After 50 billion, after 50 billion generations, what's the sum of numbers? All right, so obviously we're not going to do 50 billion generations. Maybe in 10 years we could just brute force that, but that's not going to happen now. So we need to be smart about it. And the only thing I can think of that's going to happen with this puzzle is that it has a repeating pattern. That's the only way to do this. So yeah, it definitely means I need to clean up part 1 to strip out first of all, to make this loop generic, or be able to pass in to a function, say run it this many times, or run it once, right? I need to run once, and then I need to get the state from it. And I really want to get this part to work so that I can strip out all the extraneous state at the front and not the back. I don't know what I did wrong here, though. So let's see if I can do it in a different way. I can say loop if next state dot, is there like a get front? There's a push, there's a split off, remove, extend. I just want to look at the front. The front provides a reference to the front element or none if the deck is empty. Okay, so I can probably just look at the front. If I can say while sum true equals front next state front pop front, and then subtract 1 from the current ZP. Right? Let's see if that works. And then I can do this, and I'll switch back. Oh, I'll switch back to the test input. Oh. So why isn't that working? Oh, I want to pop false. I want to pop the false ones. And now we panicked. Attempt to subtract with overflow on 71. Wait a minute, that doesn't make sense. Oh, it does make sense because what if the front of it doesn't have any entries? Yeah. So we could say while current ZP is greater than 0 and it's still 325. And now we're stripping out the front, which is nice. We still need to strip out the back. But this one doesn't require current ZP. And so we can say while sum false equals next state back. I think it's back. Let's find out. Back mute or back? Next state dot pop back. Yeah. And now we have this, whatever this is. If we do this for our test input, I'm going to hope it's a little bit bigger. We still have 3890, so I haven't broken it. But here's what I'm thinking is that this is going to generate some sort of a repeating pattern. Let's get rid of that. I'll keep this code for now. So what we can do is we figure out how long the loop is by inserting the resulting states into a hash set. And then figure out where we'll be at 50 billion. And I have no idea how to do that. My brain doesn't work that way, so I'm going to have to do it step by step, slowly by slowly. So first thing we're going to do is strip out all of this and move it into a function that does the conversion for us. Fun step. Self, and it's going to return. I guess it doesn't need to be on here because we're going to have to pass in the current point. And the current state. Oh, we do get the notes though. And we're going to return a usize and a vecdeck bool. Right? And then down here somewhere, so that's what I'm looking at. Samab says that's what I did. Yeah, I think that's the only sensible approach, right? There has to be a loop in there. So now what we're going to do is return current ZP and next state, like that. Let's just call this state, and then what we can do is say let mut current state equals state clone. This is probably using up a lot of memory that I shouldn't be using for this, but 79 now. There we go. Okay. Right, and now we actually have to do it. So we're going to say we can just say current ZP current state is equal to self step current ZP current state, and see if this still comes up with the same answer. 3890. Okay. We probably have to have an evaluation function separate because, all right, so what we need to do here is just loop until we have a, and right now I'm just going to start out by figuring out how big the loop is. States is equal to hash map new, hash set new. And what we'll do is say loop let mut count equals 0, count plus equals 1. We do have to grab the current 0 point and the current state. Put those there. Increment the count, and we'll just do the same thing we did up here. Right? Put that there. But we're going to insert if not states insert current state. Oh. Brick. And I'm just going to print out the loop count. That should be a reference. It isn't. Okay. Move occurs. Oh, here. Oh, I guess I have to clone it into the hash set. And this might take a while. Maybe I should run this in release mode, or I've got an infinite loop. I did get 1 error. Cargo run release. Yeah, maybe I have a bug here. Or the problem is I'm not stripping out. Yeah, I am stripping out the end. I was just thinking I didn't strip out the end, but I am. Right here. I'm going to print out what it looks like after, I don't know, 1,000 loops. And see what our current 0 point is. If count mod 1,000 equals 0. Oops. Yikes. Okay, this is probably part of the problem. I'm missing. Oh, because it's. I see what's going on. I see what's going on because I have the 0 point. I don't want to have the 0 point, and this is 0 here, and it's moving along. I get it. I see what the problem is. It means I have to be able to have that 0 point go negative, which is fine. Let's just make it an I64. And then every place I have current CP, I just got to look for that and change it to an I64. And then I get rid of this part here because it can go now. It can go negative now. Current CP, current CP. It's already an I64, so we don't need that. Any other places we need to do anything here? No? Okay, let's try that. Oh, I was getting a little overzealous with the replacing there. You can convert an I64 to a U size and panic. Let's not do that. Okay. Oh, let me get rid of the print statements too, because those are going to get noisy. I'm surprised Russ let me do that. It can never be -1. Maybe Clippy would complain. Okay, so 184 loops. That makes me feel a lot better. That makes me feel a lot better. So that means that after 184 generations creates one loop. So let's see if we can do this step by step, thinking by thinking. Thinking is not my strong suit. So let's comment that out. Actually, let's just pull it out altogether. So now that we know that it takes 184 loops, we know that how many loops are we going to do over 50 billion entries here? Let me just copy paste this number so I don't get it wrong. Actually, Rust has this neat thing where you can put underscores. There. So let total generations equals this number. An I32, how's that going to fit in an I32? I thought I32 went up to 2 billion. Is this even going to build? Yeah, it's out of... Dude, seriously? Okay, I64. Let's do everything in I64s. We know that number of loops, we have to count for how long a loop is. So loop count what should be the, we'll just say number of loops is equal to total generations divided by our count, right? And then we have some leftover. Smab UK says, I think my answer was a 13-digit number. Okay. So I-64 should do, otherwise we'll bump it up to I-128s. So then we say let leftover is equal to I guess it's just total generations mod count. Right? And that's how many leftover generations we need to still run after this. What we should do is get the sum for this thing. Okay, so we can say sum state, trait, summer, because it's almost winter, fn sum state self is equal to, let's do I-64s this time. And then we can impl summer for vec dec bool. Oh, we do need to pass in the current ZP, so that needs to be part of the function argument. ZP I-64. Right, and let's just grab this, stick it here, say fn sum state of self, ZP I-64, so I-64, open brace, close brace, get rid of that, change this to ZP, and instead of doing that, we do self. Does that look good? Right, so now what we're going to do here is instead we're going to see if I can just do this current state, that's some, what did I call it? State, yes. Thank you, autocomplete. Let's see if this works. Provide an argument, right? Current ZP. Cargo run. Yeah. Oh, that was even debug mode, and that loop went fast. Okay. So now here, what we're going to do, wrong direction. What we're going to do is we're going to figure out the value at this state. Wait, I'm stuck now. The value at the first state. Oh, we have to calculate the difference in values. Got it. Got it. We have to figure out how much it's worth now. And then we run it another 184 generations and how much it's worth then. And that's going to be the increment that we have to multiply and figure out. So the value after the first generation, we'll get that. Start val is equal to current state, sum state, current ZP. That's a lot of typing. And then, yeah, let's comment these guys out for now, just to get started. And then we're going to loop for count for in 0 dot count. We need to clear current states. Oh no, we don't even need to keep track of the states anymore. Right? All we need to do is do this thing. And then let end val equals current state sum state current ZP. And we can say print. And actually, I can go back into Bacon here because it's running now. Println start val goes to end val. All right, so this gives us our difference for every generation, and then we have our we have the total generations and we have the number of loops. So we can say let delta is equal to, come on, end val minus start val. And we know that we're going to be doing this number of loops through the thing. we know that we're going to be doing delta times the number of loops. And that's going to be the value. This is where I get why my brain doesn't work properly. For every number of loops, we're going to be incrementing by 36,415. Oh, sorry, no, we're going to be incrementing by delta. Do we even need this? Because as long as we know what the 0 point is going to be between entries, then we can just calculate based on the 0 point. Right, the 0 point is going to change from the start to the end. Oops, I left this there. Negative 290. Because all we need is a 0 point, because we know the final state after the loop. We do need to know how many leftover entries we have. Right, so we do need to run it this many more times, but we also need to, I guess we still need the number of loops because we want to multiply that by the delta, the current ZP, and set the new ZP by that. We've already run a couple of generations, so we have to say remaining generations is equal to this minus the count times 2. Right, because we've done it twice now. Oh, I don't know actually what the loop is, do I? I need to figure out where the loop starts. This is getting even more complicated. I only have a half hour left, and I'm probably not going to get there. We need to know where where we were. So hash map, and what we're going to do is we're going to current state clone count. So we're going to say if states.get current state, if let sum previous count is equal to this. Now we've figured out what our loop is, right? And we have an initial count. Otherwise, we're going to insert it. Is this going to run? Oh. I've got a bunch of messy code here. Hash map doesn't exist. Oops. Previous is 183, current is 184. Wait a minute. That means we've reached a steady state? That doesn't make sense because we have this. Oh, it must be moving. It must be moving one. Okay, it's probably at a different. Oh, do I have to store the 0 point there also? I do. So I'll call this p count and pzp. And then we'll say at pzp. And this is at current zp. How's that? Doesn't like that. Oh, it should be a tuple. Yeah. The previous is 183, current is 184 at negative 106. Interesting. Okay. Yeah, it looks like based on this data here, that the way this loop works is we've now reached a steady state that's just crawling to the right. It's unchanging. It's just crawling to the right. Right. And if we look here, we can see this is 184. So I did another 184 loops here and then printed out the end 0 point. And the end 0 point is also is 184 past the starting end 0 point. So I think I was worried it was going to be like, a 20 or 30 or 40 cycle sequence that would work its way to the right or to the left. But I think we can just calculate this directly. Given this information, we know that after 184, we move one to the left, no, one to the right, which means 0 point moves one to the left. So we don't actually need this loop here. What we do need to figure out is what the 0 point will be, and then just sum that up. And I think the 0 point is going to be, so we've done 184 loops. Our 0 point is 106. So we can say our remaining generations is 50 billion, minus the number that we got through. And so now we just need to subtract that from current ZP and get our answer. Right? Can we say that? Current state, some state. I don't like the name of that one now. Current ZP minus remaining generations. I should make it more generic than this. Right? We should be able to count the number of entries in the loop, and then we should be able to see how far the 0 point moves. And then we should just be able to do it. But I just want an answer at this point. I keep typing current zip. That's a big number. And it's the right answer. Thank goodness. All right. I'm going to leave the code like this, except I'm going to rename this sum state. Oops. Calc sum. There. We'll call it that. And in debug mode, it only takes, a 100th of a second. So that's not bad. Don't assume the state moves one by one at the loop. There, that's good to do. Git status. I'll remove the test input. Oh, let's remove it from the code as well. There we go. Git commit -am 2018 day 12 part 2. Not bad. Git push. Let's take a look at these commits. And we'll take a look here. Yeah. So all I did today was day 12. There we go. All right. There we go. We're getting a little bit more. I don't know what these shapes are. Windows? This looks like a question mark. We'll find out. We'll keep going.